Hello, welcome to Pre-Cal Lecture 1.11a. We're going to call this Working with Rationals. Of course, we introduced rational expressions last section. So section 1.11.1 we'll call Multiplying and Dividing Rational Expressions. So just to talk about multiplying a little bit, if you have a over b times c over d, you just multiply the tops, the numerators, and multiply the denominators. So that's just AC over BD. So let's do an example of this with a couple of rational expressions. So we want to multiply 5t squared plus 25t over 2 times 4 over 6t plus 30. Now we could go ahead and simplify this before we multiply. I could cross out the 2 and change this 4 to a 2 because 4 over 2 is just 2. But I'm just going to go ahead this first time and just multiply it all out. So we've got 4 times 5t squared would be 20t squared. And then 4 times 25t would be plus 100t. And then on the bottom, 2 times 6t would be 12t. And then we have 2 times 30, that would be plus 60. So now we need to simplify this. So what could we factor out of the top? We could factor out a 20t. And then what is left would be t plus 5. And on the bottom, we could factor out a 12. And then what's left would be, if we divide a 12 into both of these terms, we would have t plus 5. Well, that was fortuitous, wasn't it? So now we can cross out the t plus 5 as long as t does not equal negative 5. You do have to put that proviso in, because if t is negative 5, then this is an undefined expression. So we are left with 20t over 12, and then that will reduce down to, let's see, 4 would go into both of those terms. So how about 5t over 3? All right, so we multiplied it out and then we simplified, and I could have gone ahead and done a little bit of simplification before we even started. Okay, division. So with division, we invert denominator and multiply. So if we have a over b, it's not a very good a, sorry about that. There we go. A over b divided by c over d, that's the same thing as a over b times d over c, which would give you AD over BC. That's pretty cool, you know, when you're talking about time. All right, so let me go ahead, and I'm getting to the bottom of the board here. We'll go ahead and erase, and we'll do an example with division. Okay, so our example is, let's take x squared plus x over 5, and we want to divide that by xy plus y over 25. Okay, so what we're going to do then is take this second term and flip it. So we've got x squared plus x over 5 times 25 over xy plus y. Now I'm going to go ahead and do a little bit of cancellation. So We could change that to a 1 and that to a 5 because 25 over 5 is just 5, right? So we've got 5 times x squared plus x over xy plus y. Well, we could do a little bit of factoring out here. How about we factor an x out of this top parenthesis? So that'd be 5x, and what's left would be x plus 1. All right, just distribute to make sure, if you need to make sure that that works. And we could factor a y out of this first term, and then you would have x plus 1 also. So that would give you xy plus y. And we can cross out the x plus 1. So fortuitous, as long as x does not equal -1. You gotta, if you cross something out, you've got to give the proviso, the domain restriction. So this is going to be 5x over y. All right, there you have it. All right, let's do another one that looks terribly fancy. Let's say we have k squared plus 3k plus 2 over k squared plus 5k plus 4. And we want to divide that by k squared plus 5k plus 6 over k squared plus 10k plus 24. Okay, so first thing I'm going to do is flip this second one. So we've got to rewrite a lot here. Sorry about that, but that's the way it goes. On your paper, you'll have your worksheet, you'll have the original problem, so you won't have to, you can just go straight to the flip, right? So times k squared plus 10k plus 24. So I'm doing the flip of this term, or the reciprocal k squared plus 5k plus 6. Now what you want to do is factor all 4 of these trinomials. So pow, 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 pow. And then we've got a times. So I'm going to try to fit this in. Pow, 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 pow. So this makes you feel good. Just do the parentheses. You feel like you're making progress. Okay, the first one here, what can that factor into? Well, pretty easy, really. We know it's a k and a k, and then the last term is a 2, so it can only be a 2 and a 1. We have a 3k in the center, so we have a plus and a plus. How about this one? Well, k, a k, and then 4. It can be 4 and 1 or 2 and 2, but to get a 5 in the middle, I think we need a 4 and a 1. So we've got a plus and a plus. Okay, this one, we've got a k and a k. 24. Well, 6 times 4 is a factor of 24, and then 6 plus 4 makes 10. So how about plus 6 plus 4? So not too hard when you've got only pluses, you know, to think about it. And then with a 6, we could do 3 and 2 would get 5. So plus 3 plus 2. All right, you can FOIL those out, but I think we're in pretty good shape. Now, we are going to go ahead and cross some things out. K plus 1 over k plus 1. Then this k plus 2. Since you're multiplying this k plus 2 over here. K plus 4 here. K plus 4 here. And all we're left is k plus 6 over k plus 3. Okay, so we really simplified that joker down. But I've got 4 provisos that I've got to put as part of the answer. K cannot be what? Can't be -4, because that would make this parenthesis 0. It can't be -1. It can't be -3. And it can't be -2. So you have to write all 4 of those, even the ones you didn't cross out. Still, that's part of the answer, okay? So make sure you don't forget to do that, or I will have to count off on the test. Okay, it looks super fancy, and maybe it took a minute to work, but it's really not all that bad. Okay, so you can fast forward through this part if you want. Our next section's 1.11.2. Well, this one's a little bit fancier. It's adding and subtracting. Rationals. So we've got to get a common denominator on these. So it makes things a little fancier. Okay, so let's just go straight into the examples here. Let's say we've got 1 over x plus 3 plus, and I want you to leave a little room in between, 1 over x. So I'm going to show you what to do here. So to get a common denominator, really what we're going to do is multiply the two denominators together. So this denominator is missing an x, but we have to multiply the top by that. We can only multiply these by a clever version of 1 because it's the same thing then, so x over x. This side needs an x plus 3. It has an x, it needs an x plus 3. So we're going to multiply by x plus 3 over x plus 3. So now we have a common denominator of x times x plus 3. So we've got now x over x times x plus 3 plus x plus 3, our second term, over x times x plus 3. Now we have a common denominator, and we can just add the top. So we have x plus 3, and we can express the denominator just in one term and get it all into one fraction. So that's going to be 2x plus 3, I'm just adding the two x's together, over x times x plus 3. And there's nothing you can do with that. You can't like cross out that x over x because this 2x is attached to a 3. So those don't cross out. If it were just 2x and it didn't have a plus 3, then yes, you could cancel out the x's. So that's the answer, and we also need our domain restriction. X can't be 0, right? Because if x is 0, 0 times whatever this is, it'd be 0 times 3 is 0. And x can't be -3. All right, so a little bit of work there. There is kind of a shortcut to thinking about this, and I'll give that to you on this one. Especially, it works if you only have two terms. So let's say we have 1 over x plus 2 plus 1 over x minus 2. Now we could do the same thing we did up here. I could multiply this by x minus 2 over x minus 2. So that denominator, and multiply this by x plus 2 over x plus 2. That is totally fine. It will do it. But I want to show you just a little bit of a shortcut here. The common denominator is going to be x plus 2 times x minus 2, multiplying the two denominators together. And then I'm going to bring that denominator to the top left. So bring the bottom right to the top left, and then bring the bottom left and multiply it by the top right. Okay, so you're going to have x minus 2 plus, so there's the plus, x plus 2. Now if it weren't a 1, you would have to, if it were 2, then you'd have to multiply it by 2. Okay, that kind of helps us skip a step. You do not have to do that. You can do it this way by multiplying by a clever version of 1. if you want. If it's more than 2 terms, doing it this way, it will just mess you up. But if it's 2 terms, you can do it this way. So now what we have is the -2 and the +2 cancel out. You just have 2x on top. And we have x plus 2 and x minus 2 on the bottom. All right, and you really can't, you could write this, I wouldn't even want to do that as the difference of 2 perfect. 2 is not a perfect square, so we'll just stop right here. In terms of simplification, that's good enough. So when I use that method, see, we cut out a whole lot of work. But we have to do our proviso. X cannot be what? Can't be -2 or +2. All right, because either one of those would make the denominator 0. We don't care about the numerator. The numerator can be 0. Okay, the next one is pretty darn long, so I am going to need the whole whiteboard for it. And this will be our last example of this lecture. And this one looks just like a nasty problem. It's not that hard though. Let's say we have 1 over t squared plus t minus 12 minus 1 over t squared minus 7t plus 12. And I've got to make sure that I write these down right. When you write them down wrong, and I've done that in the classroom before, 1 over t squared minus 16, then you'll try to factor and it won't work and everything. So, all right, so the first thing you want to do is factor. So let's factor each denominator. All right, so we got boom, 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 boom. All right, first term is a t, so that can only be t and t. And I need a minus 12, so how about minus 4 plus 3? That'd give me a minus, no, it'd be plus 4 minus 3. I need a plus t in the center. So plus 4 minus 3. Okay, leave some space. So minus, because we're going to do our clever version of 1 here. We're going to factor. All right, t. How about minus 4 minus 3? All right, that would give you the positive 12 on the end and then the negative 7 in the middle. And then plus, I'm going to leave myself a little space here because I'm about to write something in purple. So plus 1 over, and that's the difference of 2 perfect squares. So that stuff doesn't go away. So t plus 4 times t minus 4. So if you'll notice, we have 3 different terms in the denominators. We have t plus 4, t minus 3, and t minus 4. Those are the only 3 we have. Each one of these fractions is missing one of those terms. So we just want to put the missing term in. Okay, we're going to make math do our bidding. So this one is missing a t minus 4. So we're just going to put it in. Okay, we just put it in. That's totally legal because that's just 1. This one's missing a t plus 4. So I'm going to put in t plus 4 over t plus 4. And this one's missing a t minus 3. So just put it in. T minus 3 over t minus 3. All right, now we're going to multiply it all out. Now, I've got a common denominator now. So I'm not going to write all 3 terms again. My common denominator is going to be t plus 4 times t minus 3 times t minus 4. That's the old common denominator. All right, you can see they're the same for all 3 now. Now I'm going to do the top. So 1 times t minus 4 is t minus 4. And then this is a minus. So minus, and I'm going to keep that t plus 4 in parentheses right here because I have to distribute the minus sign. If it were a plus, I wouldn't have to do that. So this is a plus. And so I'm not going to put it in parentheses. Don't have to if it's a plus. T minus 3. So that's going to be t minus 4 minus t minus 4 plus t minus 3 over all this jazz. T plus 4, t minus 3. I used to play jazz at the beginning of class when I was checking homework. All right. Now let's just combine like terms. So that t and that negative t goes away, and you're just left with a t on top. And then minus 4 minus 4 minus 3 would be minus 11. And then over t plus 4, t minus 3, t minus 4. Now we have to put our proviso, our domain restriction. What can t not be? Well, it can't be negative 4, right? That would make that parenthesis 0. It can't be 3, and it can't be 4. All right, that's part of the answer, so don't forget it. So, what's your homework from this? We're not finished with 1.11, but we're going to stop here. So, your homework is from this 1.11 worksheet, and I'm going to have you do 1 through 6. All right, so your homework is worksheet 1.11, 1 through 6. All right. Well, I hope you have good luck on that homework, and I'll talk to you on the next one.